Very good evening. Today I'm continuing the topic pointer which I have started in the last class to discuss. So we all know what pointer is. The definition of pointer is a pointer is a variable which can store the address of another variable. So the difference between a pointer variable and a normal variable is pointer variable can store the address of another variable and a normal variable cannot store the address of another variable. Normal variable is used to store the value of the variable only. That is the basic difference between a pointer variable and a normal variable. And in the last class, I already discussed two operators. One is indirection operator. Another one is address of operator. The indirection operator is used to declare the pointer variable, and I explained in the last class how it works, what is the meaning of this indirection operator. And I already discussed the address of operator. Previously, we have used this address of operator in the case of scanf function, but when we are discussing the concept of pointers, the actual meaning of this address of operator is clear to us, hopefully. It basically returns the address of operand. Now, we are going to discuss the typecasting of a pointer. The pointer variable have their own data type. Unlike basic data types, the pointer data types cannot support the implicit type conversion. Therefore, it needs to be converted to other pointer types using the explicit typecasting mechanism. Let me explain it with an example. Suppose here, the example that I considered here, say int a equal to 10 and float b equal to 12.3. What is int a? It's a normal variable a of type integer. Second line says it's a normal variable b of type float. Both are initialized at 10 and 12.3 respectively. Next two lines, we are declaring a pointer p and a pointer q. P is a pointer which can store the address of another integer variable. This line actually says as this thing. And pointer q is basically storing the address of another float variable. Again, I am telling the basic data type of p and q is not int and float. The data type of p and q is unsigned integer that I already discussed in the last class. But here, this declaration signifies p is such a type of pointer variable which is basically storing the address of another integer variable, and q is such a type of pointer variable which is storing the address of another float variable. And next two lines, we are basically assigning the value of p and q, which is address of a and address of b respectively. But if I write q equal to p, If I write q equal to p, this is not valid in C. And p equal to q, this is also not valid because the C is not supporting this implicit typecasting mechanism for the pointer variables. So that's why when I'm going to convert this pointer p to a float type of pointer, means to store the address of a floating point number, we need to explicitly typecast it. And the typecasting syntax is just like this. Within bracket, I have to write data type along with the star indirection operator. Data type and the indirection operator. So that now the P is converted to a float pointer, and now this can be assigned to Q. Similarly, in the very next line, again, this Q pointer is now typecasted to integer pointer, and now this can be assigned to P. So what we can conclude? We can conclude this typecasting, auto typecasting mechanism is not supported for the pointer variable. So we need to typecast explicitly we need to explicitly typecast a pointer variable to store it in different type of pointers. Next topic is a null pointer. What is null pointer? Null pointer is a pointer value that points nothing. Better to say, null pointer is a pointer value that points to no valid location. And null pointer is a constant pointer, that is compatible with any pointer type. Int star PTR can be null, a float star PTR can be null, a cat star PTR can be null. Fine. So what is the meaning of null pointer? According to the definition of pointer, we know a pointer is a variable which can store the address of another variable. But here, when I am talking about the null pointer, it means it's such a type of pointer which is not pointing any valid location. Rather, it's a constant pointer and represented by address 0. Represented by address 0. Second point, it is not compatible with function pointers. Function pointer is not known to you, so that's why I will discuss this point later on. Third point, when a pointer is equivalent to null, it is guaranteed not to point any variable defined within the program. So if it is declared as null, that means it is guaranteed that it is not pointing any variable defined in the program. A null pointer is an address that is different from any valid pointer, and assigning integer constant 0 to a pointer assigns a null pointer value to it. Let me explain this point through a program. Like this. One approach is, say, just a minute. Suppose I declare a pointer p which is integer, That means P is a pointer which can store the address of another integer variable. When I'm initializing the value of the null, the star P equal to null, and in the very next line, when I'm going to print the value of P, what will be the output? Let me check what will be the output. Yes, the output of P is equal to 0. The output of P becomes 0, right? Why P becomes 0? Because I just discussed, when we are talking about a null pointer, that means it is not pointing to any valid location, and thing is that the value of a null pointer is a constant value which is 0. So when I am assigning value null to a pointer variable, the address of that pointer variable, the address of the pointer variable become 0. Otherwise, if it is not assigned to 0, so that means in that case, the pointer variable is basically taking a garbage value. And you can set the null pointer in this way also. I'm taking a pointer variable P, considering a pointer variable P in my program, and I'm assigning value of P equal to 0. So when I'm setting the value of P equal to 0, that means it's a constant value 0 set to P. So P will behave like a null pointer. And if you execute this program, same result is also here, where P equal to 0. So hopefully this much is clear to you. Fine. Moving to the next topic. Okay. Next topic is void pointer. What is void pointer? What is null pointer? Just I discussed. What is void pointer? It's a typeless pointer, or better to say, it's a generic pointer. What is the meaning of void pointer? Void pointer is a pointer which may store the address of any type of variable. That means the address of any type of variable means void pointer is a pointer which can store the address of any type of variable. What it means? It means it can rather it can store the address of any data type. So this type of pointer is called typeless pointer or generic pointer. So far the variable that we declared, like int a, float a, char a, double a, can we declare void a? Answer is no. But we have seen that yes, a function can return the return type of a function, better to say, the return type of a function may be a void. But I can declare int star ptr, float star ptr, cat star ptr. What is the meaning of int star ptr? Meaning is ptr is pointing to a variable. Rather, ptr can store the address of another variable which is integer type. When I am writing float star ptr, it means float is a pointer type variable which can store the address of float variable. And when I am writing cat star ptr, it means ptr is a pointer variable which can store the address of another character type variable. Now the question comes, what is the meaning of void star ptr? And it's a valid declaration in C. The meaning of void star ptr is a ptr is such a type of pointer variable which can store the address of any data type variable. But there is a limitation of using void pointer. What is the limitation? Look at the highlighted part in this screen. When I am using void pointer, which is used to store the address of any type of variable, yes, that's true. But thing is that the compiler has no information that how many bytes of data it will retrieve from the memory starting from stored address. When I am talking about integer pointer, I know the size of integer variable in DEPC compiler is 4 byte. And depending upon this 4 byte, the compiler can assure you he has to read 4 bytes. Rather, when the program executes, program knows he has to read 4 bytes to retrieve the data from starting address. Right? 32-bit he has to read. It has to read. Similarly, when I'm talking about cat data type, I know character takes 1 byte. So compiler is completely aware that it has to read 4 byte, rather, sorry, 1 byte, rather 8 bit to know the value of this pointer variable. But when I am using void pointer, it's because it can store the address of any other type of pointer. So it's completely unknown which type of pointer address it is basically storing. So that's why it is tough for the compiler. Rather, compiler is unable to retrieve the memory starting from address. Therefore, indirection operator, matlab star operator, when I am try to show the value of the pointer variable, that is star r, or rather star ptr, we cannot use that thing on void pointer. So that is the limitations of void pointer. So you can use the void pointer to store the address, but you cannot use the indirection operator on it. Why we cannot use? This is the reason. Compiler has no information that how many bytes of data it will retrieve from the memory starting from the stored address. Try to show an example. Look, in this example, what I'm trying to do, int a float b, int star p float star q void star r. So what is p? P is a pointer variable which can store the address of another integer variable. Q is a pointer variable which can store the address of another float variable. R is a pointer variable which can store the address of any other data types, any data types address. But we cannot use the dereference operator, rather indirection operator on it, because compiler don't know how many bytes of data, or rather how many bits of data needs to retrieve when I want to know the value for this pointer variable. Very next line what I am writing, p equal to ampersand a, q equal to ampersand b. So p is storing the address of a and q is storing the address of b, right? Star p, it's giving you the value of a, right? That is discussed in the last class. It is giving you the value of a, that is 10. Next line what I have written, r equal to p, it is valid. R can store the address of p because r is a void pointer. But when I am going to print the value of star r, that is not valid. Let me check. If you compile and run this program, look, this line will give you an error, dereferencing void star. It's a warning, dereferencing void star, right? So when I am commenting this line, now this is fine, we'll execute fine. Yes, the output comes only 10 because, let me share the screen. Yes, the output comes 10, which is basically prints the value of what? Prints the value of star p. The star p value is 10. So after few minutes, I will come back again to the topic void pointer, because naturally a question arises to you or arises to all of you. What is the use of this void pointer actually? If I don't retrieve the value of the pointer variable uh, using a pointer variable, then what is the actual use of this void pointer? I will come back to this question later on. So moving to the next program. Before moving to the next program, let me introduce the topic, how pointer variable can be used in a function. All we know about functions, because we already aware how function works in a program, but now we are using pointer in a function. So first program, just try to follow me. It's a very simple program I am going to write. Just addition of two numbers. We have already done this program through value passing. Using function, we have already done this program. But now we are doing this program using function and pointer both. So just like previous one, I have to take two integer pointer, rather two integer pointer in the parameter list. Instead of normal variable, we have to take two integer variable, two pointer variable of type integer in the parameter list of add function. So just like previous program, try to remember the previous program. It was just like this: printf, enter two numbers, enter two numbers, I'm scanning the two numbers. Both are in x and y, ampersand x comma ampersand y. Then I'm calling the add function. That function is returning an integer variable. I'm directly prints the result. So printf %d comma, I'm calling this add function. Now I am not passing the parameters. Later on I will pass and return 0. That is the definition of main method. Not yet completed. I will pass the value of, I'll pass the parameter of add functions later on. Now I am going to the definitions part of the add function. Say int star p int star q. So int r equal to star p plus star q, return r. Try to remember what is the meaning of this star p and star q. Just try to remember of the previous class. Star is called the dereferencing operator, better to say indirection operator, which is used to retrieve the value of the pointer variable. Star p, p will be replaced by some address. P equal to ampersand x, or p equal to ampersand a, or p equal to ampersand m. P will be replaced by some address. So far we have learned this thing. And what is the meaning of star p? The meaning of star p is value of that particular address. Fine. So now what we need to pass as a parameter of add function, as because the add function takes two integer, rather two pointer variable. What type of pointer, that is not the matter. It takes two integer pointers, so we need to pass address, because previously when we passed parameter in a function, what it does, it basically replaces the formal parameter by the actual parameter. The formal parameters, here the formal parameters are p and q, are just replaced by the value of actual parameter. If you don't use the pointer variable, it will be just like add x comma y, and here in place of star p and star q, it was p and q only. The x will be copied to p and y will be copied to q. And I discussed also earlier that the address of x and y and the address of p and q is not is not same. They are completely resides in the different address. So that's why as a consequence, we have shown you that the result of a swapping function remains unchanged in the main when we pass it to a value. So here, instead of variable, we have to pass the address of that particular variable. Am I correct? Yes. Why? Because the list of parameters are what? Pointer type of. Because list of parameters are of pointer type of, definitely the address, we have to pass the address to that pointer variables. So here we have to pass the address of two variables for which we are calculating, rather we are using the function add. So what we passed over here, we have passed address of x and address of y. Now what is the consequence of using this? P is replaced by address of x, Q is replaced by address of y. Say I am considering the address of x is say 3040 and address of y is 5040. So you have passed 3040 and 5040 as a parameter of this add function. So P gets replaced by 3040 and Q gets replaced by 5040. So what is the star 3040? Value at 3040. That means value of x. And what is the meaning of star 5040? Definitely the value at address 5040. That is actually the value of y, because it is y's address. So using indirection operator, I am considering the value of P and considering the value of Q, adding those two values, storing it inside R, return R to the caller, and the function is called from the main function, and using printf, I just printed the return value. So definitely it will give you the correct result. Let me run this program. Enter two numbers. Say I'm entering 5, 6, and the result becomes 11. So hopefully it is clear to you how pointer can be used in a function. So what we are passing here, we are not passing a value to the function. Rather we are passing the address of a variable to the function. Previously, so far, the parameters that we pass to a function is nothing but a value. And this concept is known as call by value. We discussed it earlier. But today, we learned how to pass an address to a function. So this concept is known as call by address. Some books refer this concept as call by reference. If the question comes, what is call by reference in C? You have to justify the answer with this sort of example. But the thing is, call by reference is not the similar to this one. Call by reference is different concept which is implemented in C++, but some C books are considered this concept as call by reference. Actually, this is known as call by address. So what is the conclusion? We conclude this in this we conclude this we can call it as call by address slash call by reference, but this is not actually the call by reference. It's different concept which is implemented in C++. Now we are moving to the next example of call by reference. Try to write one more program. It's a swapping function I'm going to write, which I already discussed with you using the concept call by value. Say the signature of the swap function is void swap in star init. Try to remember the earlier program where I have considered swap function passing value only. So here I am passing the address of the variable to the function swap. So considering two variables p and q, taking input for two variables. Just like this. Then I'm calling swap function with the parameter. Instead of value, you have to pass the address %q, %p, and %q. So now, just like previous program, I print the value of p and q before swapping and I will print the value of p and q after swapping also. Same line, I will show after calling the swap function. Now try to define the function swap. It's a void swap which is taking two integer parameters. Say it is int star x, int star y. Try to understand. Normal temp variable taken. Temp equal to star x equal to star y, and star y equal to temp. That is the definition of the swap function. Swap this program. Fine. So before executing this program, try to understand how it works. Look, I have taken two variables, P and Q, and I have passed the address of P and Q in the function swap. So passing before passing the address to the function swap, I have just printed the value of P and Q. So consider the value of P is 10 and the value of Q is 15. Consider it. The value of P is 10 and the value of Q is 15. So what is the output of this line? 10 and 15. Output of this line. Say the address of P, consider the address of P is 3040, address of Q is 5040. So you have passed address of P 3040 and address of Q, that is 5040, to the function swap. Understood? Okay. So now X gets replaced 3040 and Y gets replaced 5040. So what is the value of star 3040? If you interpret it, the meaning will be value at address of P, that is star X, and value at address of Q, that is actually your star Y. What you are doing in the definition? You are storing the value at address of 3040 to 10, value at the address 3040 will be the value at address 3040 will be the value at address 5040, and the value at address 5040 will be the value of temp that you have stored earlier in this line. So try to understand the concept. We are considering the value at address 3040 and the value at address 5040, which is basically the original address of these two variables P and Q, which are actually the original address of the variable what P and Q that we have passed. So when we are executing this set of instructions on the value on the variable P and Q, which are stored in the address of 3040 and 5040, the swapping operation is done on the address 3040 and the 5040, that is the original address of P and Q. So the reflection of this swapping operation is done in the original address. In our previous program, when we have passed the value to the parameter X and Y instead of the address, the reflection of the swapping is not yet done in the original variable. Why it is not done? Because the value is copied to the variable X and Y. Consider it X and Y instead of star X and star Y. And here, instead of ampersand P and ampersand Q, we have passed P and Q only. So the value of P will be copied to value of X, and value of Q is copied to value of Y. the address of P and Q and the address of X and Y is completely different, and the swapping operation is done at the address at the value of X and Y. So that's why the swapping reflection is not done in the address of P and Q in the case of call by value. But here, instead of value, we have passed the address of those two variables. And depending upon those address of those two variables, we are doing the swapping operation. That's why the swapping operation must reflect in the original address, and we get the swap value of P and Q when you are printing the value of P and Q after calling this function swap. So let me check and execute the program. Enter two numbers, say 10, 15, I can see that. Yes. Let me share the screen. Look, the value of P and Q, initially it was 10 and 15 before calling the function swap. After calling the function swap, it becomes 15 and 10. So that is the another example of call by address slash call by reference. And this is the advantage of using address of a variable, passing address of a variable as a parameter of a function, because the operation is done in the original memory location. Otherwise, when you pass as a value, it will be copied to some different variable, and the reflection, if you modify the value of that variable, that reflection is not done in the actual parameter. It is done in the address of formal parameter. So that's why if you cannot see the result, reflection of the result in the original cases, original variables. So this is the advantage of using call by address rather using call by value. So coming back to the slide, this is the probably the last slide for today's lecture. So going back to the previous question, what is the use of void pointer? Because we have seen the indirection operator cannot work on the void pointer, right? So what is the meaning of this? The meaning of this is we cannot retrieve the value of the pointer variable by using operator star, because compiler doesn't know which data type's address it is storing. That's why it cannot retrieve. It is not known to the compiler how much byte or slash bit needs of data needs to be retrieved for showing the result. So that's why star operator is not functionable in this case. Then what is the use of this void pointer? Void pointer is used to write a generic function which can accept any type of parameter. What is the meaning of generic function? Generic function is basically allows you to define a function which are basically replacing a set of similar type of functions. I will show an example after this slide. So This is the use of a void pointer. What is the use of void pointer? It can be implemented to define a generic function. Just remember this line. What is the meaning of generic function? Generic function allows you to define a function which are basically replacing a group of similar type of functions. If you think about, for an example, you can think of it just like this way. You have a function. That type of example I will just show you in the after this slide. You have a function which are taking pointers. One function is used for the purpose of swapping two integer variables. Try to remember, try to understand. And you have another function which are swapping two float type variables. The definition of this function is almost similar. 3 lines. You have to store the value of star x into a temporary variable. Star x will be star y and star y equal to 10. But the difference is data types of the parameter list. When I am talking about the swapping operation of two integers, I have to take parameter int star comma int star. When I am talking about swapping of two float variables, I have to consider float star instead of int star int star. But the definition part is same. So this is the similar type of functions. This we called here similar type of functions. A group of functions which do the similar task, but the data type of those functions are different. Rather, parameter list of those functions are different. So can we replace these two functions by a generalized function? The answer is yes. In that case, we need to take help of this void pointer. And we are just going to do this. That is the use of void pointer. And the next line, that the character is always a byte. This concept is basically implemented in the program. That's why I have written this line over here. Look. Back to the program. The program just I have talked about. It's a function. It's a program consisting two functions. One is swap I, another one is swap f. Swap I is taking two integer variable. That's why considering two integer pointer. And swap f is basically swapping two float variables value. So that's why I considered two float star. Just called swap I and swap f with the parameters ampersand I and ampersand j. I and j are two integer variables. In case of swap f, I have just passed two parameters ampersand x and ampersand y. Both ampersand x and y are the float type of, right? And this is a 0.2. The meaning of this 0.2 is after decimal 0.2f. Actually, instead of %f, I have written 0.2f. Earlier, probably we have used this concept in our one program. What is the meaning of this 0.2f? The meaning of this 0.2f is basically a format specifier of f. It's a type of format specifier of f. We are just formatting the output. Means after decimal places, it will print 2 digits only. If you not give it, it will show you normally in DebC, it will show you 6 places after decimal. So as I mentioned, 0.2, 0.2, so it will display you 2 decimal places digit, up to 2 decimal places. So now coming to the definition part, it's very much similar to our previous program. In temp equal to star A equal to star B, and star B equal to temp. And look at this one, almost same. Instead of integer parameter, we have to take this float parameter, and definitely the data type of temp is also float. So the conclusion is both these two functions, swap I and swap f, are taking same number of parameters. Data type of those parameters are different, and their definition part is also almost same, except data type part. Now, the question is, can we generalize these two functions into one? Yes, we can do this. And that concept is called the generic function. Try to write. This is the next program. So let me check the output for this program first. Look, it is showing up to 2 decimal places. Initially, the value was I and j, it is 1020, and the value of x and y, it is 12.3 and 53.4. So it just gets swapped. It just gets swapped, and the value becomes, sorry, this is not. The value becomes I value is 20, j value is 10, x value is 53.40, and y value is 12.30. It just gets swapped. Very much similar to our previous program. Now we are coming to the last program, that is the generic cases. We are doing the same thing, writing a generic function. Look, instead of int star float star, look about the function. Instead of int star float star, we have written void star. Swap function, try to understand the swap function, which is basically the generic function of the previous one. Instead of int star float star, we are taking void star, because the advantage of void pointer is it can point to the address of any data type, rather it can store the address of any data type variable. So whether it is int, whether it is float, whether it is char, it can store the address of any variable. And what about the third one? It's a normal integer parameter. It's not a pointer parameter. What is the use of this parameter? This parameter actually gives you how many bytes is used for the parameter we have passed to this function. Means if it is an integer parameter, it will take how much? 4. If it is a float parameter, it will take 4. In case of DebC, I am talking about. And if it is a character parameter, it will take 1. Understood? So that's why the third parameter, when I'm calling this function, the third parameter I have passed size of int for the first case. For the second case, I have passed the size of float. We know what is the size of. Size of is a special type of operator. Size of is a special type of operator, which is basically returns the size of the data type in terms of byte. So as because when we are dealing with the parameters which are integer, that's why we need to know how many bytes it will take to store that data type. So first case it is integer, that's why I have passed size of int. Second case, size of float. Understood? And I have passed ampersand I and ampersand j, ampersand x and ampersand y. Now we have to discuss the second part. And obviously, after calling the function swap, when I print the value of ij and xy, definitely it prints the swap value. Now I am moving to the definition part. What is this definition part? Definition part will not be same as the previous one because we know that this dereference, rather indirection operator, is not working in this case of void pointer. Understood? Just a minute. Yes. So here the definition is a bit different than previous one. Why? Because the indirection operator is not, it cannot work on the void pointer. Star A cannot give you the value. Similarly, star B cannot give you the value. So what I have done here. So star A and B, that is taking the parameter ampersand x ampersand y in the second case, and first case it is ampersand I and ampersand j. Nice. So A and B is basically considered the address of variable ij in the first case. For the second case, it is variable x and y. And what is for the third parameter in 10? For the first case, the size of integer. For the second case, it is size of float. Obviously, the value is integer because size of operator returns the size of a data type in terms of byte. Now, look what we have done. Cat star p star q comma temp. Character pointer. Why we consider character pointer? Because for all the compiler, character data type is taking 1 byte. That's why we consider character pointer here. And we have typecasted this void pointer to character pointer. So address A is in now P, address B is in now Q. And we have typecasted A and B, both void pointer to the character pointer. And I've stored this P, the address, whatever the address which is stored inside A to P, whatever the address stored inside B is in Q. So just while, look at this part, while n greater than 0, temp equal to star p equal to star q equal to temp. So if you think about the n is the number of bytes, n is the number of byte. So first byte value is in temp. For the second parameter, first byte value, second byte value, look, P and Q. This is the, when I'm converting it to the character pointer, it is basically 1 byte address. And n, I know how many bytes our original value is. So what I'm doing here, I am just swapping the value byte wise. This is the swapping of the first byte. P equal to A, that means it is actually the first byte. P equal to 1 byte. Original value is not 1 byte. A is the address, but I don't know how many bytes I have to read, because void pointer doesn't know about the number of bytes of the data type. That's why it knows only the starting address, but it doesn't aware about the ending one, because it doesn't know how many byte it needs to read. So that's why we have taken one more parameter which will guide us how many bytes we need to read, that is our n. And we have just iterate a loop until and unless n greater than 0. So first byte, starting address, first byte we have swapped. Fine. P plus plus, I'm moving to the second byte. When I'm incrementing the pointer, the beauty of the pointer variable is that I will discuss in the next class. The beauty of the pointer variable is when I'm incrementing a pointer variable, it will not increase the value only by 1. It will increase the value depending upon the data type. If the data type of P is cat star, then it will increase by 1 byte. Matlab, if the original, say, the value of P, starting value of P is 3205. As because P is a character pointer, it moves to 3206, 1 byte, next address. But if the pointer variable P is a float star P, and if you increase P plus plus, if you write P plus plus, P will move 3205 to 3209. The result of P plus plus will not be 3206. Why? Because you considered the data type of P is float star, and the size of float I know 4 bytes in the case of DeepSeek. So that's why it depends upon the data type of the pointer variable. So as because P and Q in this case is character pointer, so definitely P will point to the next byte. Similarly, Q will also point to the next byte. And n minus minus. Definitely if the n is 4, 4 becomes 3. Because we have passed how many bytes we have to read to swap this to value. That is unknown to void pointer. Void pointer not knows how many bytes to read. That's why indirection operator is not working over here. That thing I am achieving in the another way. I am passing how many bytes needs to read. Character pointer, character data type size is 1 byte. So that's why I'm considering the character pointer. Starting byte assigned to P and Q, and we are increasing P and Q n times because I have to read n bytes, and I'm decreasing the value of n each step by 1. So this is the generic definition of the swap function. So try to execute the program. Yes, it is showing the output. Very nice. Let me share. Look, so same function definition is working for the integer swapping as well as floating point number swapping. So this is the example of generic pointer definition where we can use the void pointer. So this is the advantage of using void pointer. So the last line of the slide, this is the point that I just used in the program, that character is always a byte and a character pointer works as a byte pointer. So when we increase the character pointer, so it will point to the next byte. And the size of operator calculates the size of the data type in terms of bytes. So hopefully this much is clear to you. Thank you. Thank you very much.